Okay, so let's do number 4. In fact, it's number 3. And it says complete the electronic configuration in terms of subshells for the following elements or ions. And it's all elements and ions. So let's look at the elements. Calcium is an element. Iron is an element. Bromine is an element. Copper, potassium, and selenium. These are all the elements. Okay. What about the ions? Let's say the ions. So the ions is calcium 2 plus. It's an ion. Chlorine minus. Sodium plus. Silicon 4 plus. So this is significant because it's going to determine just how many electrons are in the shells of these, the subshells of these elements or ions. Okay, so let's start off with calcium. If you go to the periodic table, calcium is right here, and calcium has 20 electrons. So we're gonna go home onto here and say that calcium has 20 electrons. Okay, what about calcium 2 plus? What does calcium 2 plus, what does 2 plus mean? 2 plus just means it's got 2 excess positive charges. And we know that the protons are positively charged, which means that this ion contains 2 more protons than it does electrons. So if initially it had 20 electrons, it means that it lost 2. So instead of 20, it's got 18, and we'll leave it at that. Okay, so calcium 2 plus is 18 because it's lost 2 electrons. Chlorine has actually gained an electron, that's why it's negative. So we just go to the periodic table and we look for chlorine, and initially it's got 17 electrons, but because it's gained an electron to get a negative charge, we're just going to put that is got 18 electrons. Iron is Fe, and iron is 56. Where's 56? Where's 56? That's 57. 56 is hiding. Okay, let's just look for Fe. Can you see Fe anywhere? Don't tell me it's missing. Oh, that's barium. Oh, there it is. It's 26. It's 56, but it's up here. I was looking at the atomic mass instead of atomic number. Right, so iron has 26 electrons. Okay, so iron has 26 electrons, so we're just going to put the 26. Bromine, on the other hand, bromine is easy to find. Bromine is right here. Bromine, fluorine, chlorine, iodine. So bromine is 35. Okay, bromine is 35. So we're going to put the 35 electrons here because it's just an atom, just the element. It's not an ion. Copper. Where is copper? Copper is just here, and copper is 29. Okay, so we're going to go here and say that copper has 29 electrons. Sodium plus. A plus on the sodium means that it's lost an electron. That's why it's an extra. So if it loses an electron, it means from 11, it's gone down to 10 because it's lost 1. So So we're going to put 10 here. Okay, 10 electrons. Silicon 4 plus, it means that it's lost 4 electrons, which is why it's 4 plus. So it had 14. So if it's lost 4, it is left with 10. So we're going to go ahead and put the 10 here. Potassium is K, group 1 element with 19. And here is just K, so it's 19. Selenium, where is selenium? Selenium is right here. It has 34. So we're going to go ahead and put a 34 on selenium. 34. Okay, now let's find the electronic configurations. So for calcium with 20 electrons, it's going to start off as 1s2, 2s2, 2p6, 3s2, then 3p6, and 4s2. Let's see if we've got the correct. So that's 2, 4, 10, 12, 18, 20. Okay, that's done. Calcium 2 plus is 18. So looking at this one, you can see that calcium had 20 and ended up in 4s2. So the calcium 2 plus is going to be missing the 2 at the end. So it's going to end on 3p6. So that's an easy one. 1s2, 2s2, 2p6, 3s2, 3p6. And that's it. The same with the next one. The chlorine also has 18 electrons. So it's going to be exactly the same. With 18 electrons, it's going to be 1s2, 2s2, 2p6, 3s2, 3p6. Iron has 26. So it's going to go all the way. Just like calcium, it's 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Then after 4s2, it will need, because after 4s2 it's got 20, so we only need 6 more. And we go into 3d, so 3d6 for the 6 more. Okay, then E is bromine. Bromine has 35, so we can go as far as just like the 20 first of all, which is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. So after the 4s2, we've got a complete 3d10. Now let's take stock and see how much is left. So we've got 2, 4, 10, 12, 18, 20, 30. So we only need 5 more. And we go into the 3p, and it is going to be 3p. No, we've already had 3p. So it's going to be, we've already had 3p6. So it's going on to 4p. Because we've got 4s2. So it's 4p6. I need to delete that and put 4p6 here. 3d10, 4p6. Okay, then for 29, it's almost copper is 29, and copper is 6 electrons less, but there's something special about copper on the 4s, and we're going to find out when we get there. So it's 1s2, 2s2, 2p6, 3s2, 3p6. Instead of 4s2, we have 4s1. Okay, so far we have 2, 4, 10, 12, 18, 19. So we need 10 more. And we're going into 3Ds. So it's going to be 3D10. And voila. These ones are quite simple. 1s2, 2s2, 2p6, and that's it. That's already 10. Same here. That's already 10 electrons for silicon. 4 plus. Potassium is 19. We saw what happened with when we had 18. We went as far as 1s2, 2s2, 2p6, 3s2, 3p6. Then after that 3p6 we have 4s1. Okay, for the 34 we can go to the 35. With 35 this is what we had. So with 34 it's just one less, so it's 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p, that was 4s2, so this should be 4p, 5. Okay, let's take stock. 2, 2, 4, 10, 12, 18, 20, and that's 35. So that should be a 4. That should be a 4. Okay. 3d10. So for A, we've got, so for P, this should have been a 5, not a 6. Okay. We need to learn to count properly. So that's 2, 4, 10, 12, 18, 20, 30, 35. Yeah, so that's a 5, not a 6. Okay, so that's why it seemed as though it was going to give us a problem, right? So that's it for number 3. I'll see you when we do number 4.